understand how statistics is related with Excel, how it is related with the SPSS, and how it is related with the RStudio as the main tool here. Is the backbone of data analysis. That's what you're supposed to know. You cannot be a data analyst, you cannot analyze data, and you don't have statistics knowledge. So it enables us to extract meaningful insights from data. In RStudio, we can perform statistical analysis using built-in functions and packages that we are going to see. We are supposed to cover it today very fast. We are going to see all the libraries and packages in R, and we are going to see the most important ones that we are supposed to learn now as us. We are not going to cover everything. So the key concept in statistics, in this case now, there are three. As you know, we have two types of statistics. Number one, we have the descriptive statistics, and the second one is always inferential statistics. So descriptive statistics, it gives us the summary of our data. That is measures like the mean, the mode, the median, standard deviation, and variance. While inferential statistics, it makes prediction using hypothesis testing, regression analysis, and confidence interval. And the reason as to why we are supposed to have Excel, I'm going to show you how to run some descriptive statistics in Excel, but that is not our focus. Our focus is in the next class, we are supposed to cover the hypothesis testing. We want to see how we can do hypothesis testing, regression analysis, and the application in the real world data sets. We have several statistical tests. That is also, this is something that it really used to disturb my head, because every new day I will wake up and meet a new statistical test. So I decided to come up with a blog. I wrote a blog talking about all statistical tests that someone can ever meet, and that is the time I came to realize that we have very, very many statistical tests. But the most common ones are tests like the t-test, we have chi-square test, the ANOVA, correlation analysis, and regression. And you will come to realize that when you go to Excel, you can run some t-test, you can run the chi-square test, and try to make decisions from a statistical point of view. So we are going to having that we are supposed to cover introduction to statistics. I saw it better if we can also see some one or two statistical tests with us, and during your free time you can go and read them in details. I'm presenting my screen, and this blog page is available in the site. So this is something I wrote in December 28, 2024. So it means it is up to date. So you can see also descriptive statistics is a statistical test by itself, where you are trying to get the mean, mode, median, those percentiles, standard deviation, and all that. Then we have some two other major branches of statistical tests, and that is the parametric test and the non-parametric test. So the parametric test is where you're going to meet things like the t-test, you're going to meet the ANOVA. ANOVA in full is the analysis of variance. And under the non-parametric test is where you're going to meet the Spearman's rank correlation, you're going to meet the Mann-Whitney U-test, Wilcoxon signed rank test. So the difference between the parametric and the non-parametric test is that the non-parametric tests are used in cases whereby the sample size you're having is small. So if you're having a sample of like 30 people, 30 patients, then in that case, you have to know which statistical test am I going to use to make a prediction. You cannot be having a sample of 10 people and I want to do a prediction using a t-test or an ANOVA, the analysis of variance, because all statistical tests individually have their own assumption. You see? So when it comes to non-parametric tests, they usually work with a small sample size. So the moment you are doing a statistical analysis task, and you have a sample size of 20 people, and you present your work tackled with an over test, then you are out. Like totally your work cannot be reviewed because you are supposed to use a non-parametric test. So that is the reason as to why I saw it better to introduce you to statistical tests. We have chi-square test. The chi-square test will always give you a value, a calculated value that you will compare with the value in the table and then be able to make a decision. Same to t-test. When you run a t-test in Excel, you will get a p-value. How are you going to make a decision from this p-value? I think this example is going to be better to introduce you into the statistical test for those maybe who are meeting it for the first time. There's a time I was doing some analysis for a sales store, a supermarket sales store, and I wanted to know the relationship that exists between televisions and woofers in a supermarket. So I decided to run a t-test in Excel, and from the t-test, I got a value of 0.002. So after getting that value, what next? You should be able to make a conclusion from the value that you have found. And I said, since the p-value is a 0.002, which is less than 0.05, then it shows there's a high. Okay, it shows that there's a high what? It shows that the relationship between television and woofers is statistically significant. You see, that is how this test will help you make a decision. You make a decision for patients somewhere, maybe malaria. You're trying to compare maybe group A and group B between some different time intervals. Then you see how you can make a decision. And for you to make a decision, you must have a hypothesis. So we also have hypothesis testing, where you meet the Z test and the F test. We have survival analysis test for those who want to, mostly this one is for a statistician in the health field. Those who are focused with the survival analysis test, and you have to have deep knowledge in time series analysis because it's the one that really focuses on survival analysis. And you will meet the Cox proportional hazard model. There's a time I was having was it a data for cancer patients, and I wanted to perform some survival analysis for these people. And I can recall doing running some Cox models in SPSS. So you'll see that all these tests are also available in SPSS, and that is the reason I will show you maybe one or two things. We have multivariate tests. The most common one is the MANOVA. So MANOVA is just like an overextended one. So here is the multivariate analysis where you have many variables. We have advanced machine learning based tests. We have tests for normality and homogeneity. There you're going to meet the Kolmogorov's-Manov, which is the most common one. Then you have also the Bayesian test. The Bayesian test, sometimes they are very challenging. You have to be very keen. So it's a PDF. I wrote this blog and also attached a PDF. You can download it from this site and use it during your free time. So apart from statistical tests, I want us to compare these tools. I want us to compare SPSS, Excel, and R. And I want you to know the difference between SPSS and R. So according to me, I always say this. If you tell me to tell you the difference between SPSS and R, SPSS is for lazy people. Like if you don't want to keep on coding, if you don't want to write codes for hypothesis testing, if you don't want to write code for all these statistical tests, someone sat down and coded everything in the background, then developed an application that you can just click. That's why you have to buy it to be able to use SPSS. So everything that R can do, SPSS can do, but SPSS sometimes is prone to truncation errors, and When you truncate values in statistics, it may affect the way you're going to make your decision. So when it comes to open source, R is open source. You don't have to pay for it to use it, but SPSS and Excel, you have to pay for it. And that is why you will get when you buy a new laptop and you want to activate Windows, you want to activate Office, you have to go to a cyber person and the cyber person is going to install a cracked version. And the same way I shared a cracked version of SPSS to you guys, so they are not open source. Data handling, when it comes to data handling, R is advanced. It can do literally, you are not limited. You can write code to any extent to handle your data appropriately. SPSS is moderate and Excel is basic. So you see, Excel, when it comes to data handling, Excel is basic, SPSS is moderate, and R is advanced. When it comes to statistical test, R is extensive. It can do every kind of test that I've shown you. SPSS is limited. Why? SPSS has more than 4 types of premium packages that you have to pay for. For example, you can pay for a package what of Python and R. So when it comes to, okay, I'm coming there. I was talking about statistical tests. SPSS is limited. How? In SPSS, you'll get when you pay for a package of maybe, let me talk of, we have a package of $90, $200 and $300. So if you pay for a package of $90, you cannot perform the Kolmogorov's Manov test. It is limited to only users. It's only users who have paid for the $300 package can do it. So you'll get that this level of amounts that you pay are divided, and some features are locked out depending with the package that you buy. When it comes to Excel, Excel is very basic. Excel has very few tests, and I just want to show you as we move on. When it comes to graphing, R is customizable. You can customize the graph as much as you can. You feel that the scale that you've generated the graph with is not okay, you go and edit. Maybe it's a 5, 10, 15, 20 scale. You come and work with the 2, 4, 6, 8, or 1, 2, 3, 4. So you can do literally anything. Okay? When it comes to SPSS, it's limited. The graphing, the graph that the graph feature for generating graphs in SPSS is limited. Whatever has already been coded in the background, you have to use that. Okay? When it comes to Excel, Excel is also basic, because who even wakes up to do data visualization in Excel unless you are not okay. Okay? When it comes to automation, R is good in automation because we have Shiny. You can extend to making Shiny apps and upload them to the Shiny website. SPSS is, you cannot automate SPSS. And Excel is limited because Excel has the refresh feature. Anytime you're doing edits, the same way you can do it in Power BI. Yeah, Kevin, I know you get it, even Felix. So the same way you can refresh in Power BI whenever you make changes in your data, then the changes will appear in Excel in your analysis that you've done. In SPSS, in R, you can fully do that. In SPSS, you can never do it. You change a value somewhere, you already generated analysis, you have to repeat it again. So automation is, and right now in the world of AI, artificial intelligence, who is willing even to work with a tool that is cannot support automation? No one. So you'll come to realize that out of all these, R provides more flexibility, automation, and extensive statistical capabilities than both SPSS and Excel. But generally, they can all perform these tests. They can all visualize that at the end of the day. You can use all of them to do your analysis. But you can never, at least you can compare SPSS to R, but you can never compare R to Excel, because it's way above. R is way above than Excel. I was to show you something here. In Excel, there's something that comes, but it's not always readily available. You have to activate it. And I was showing Felix the other day how to activate the data analysis tool in Excel. You just go to option, file, you click on file, you go to options, and you go to add-ins. It's an add-in feature. You click on add-ins, you're going to get it. I hope you guys can see my screen. I'm presenting Excel. So once you come here, these are tabs in Excel. You come on the data tab here. When you click on the data tab, you'll be, after activating the analysis toolpack in the files option, you'll be able to see this thing here, data analysis. And when you click on this data analysis, it's a pop-up window. Sometimes Google Meet does not show the pop-up window, or not sometimes, but Google normally doesn't show the pop-up window, so you cannot see it. But you will see some few types of tests here: ANOVA, ANOVA, ANOVA for two-factor without replication, correlation, covariance, the descriptive stats. You'll see the F-test for the analysis, histogram. You'll see some few tests here, but they are not all. That's why I said it's limited. You can run this test in Excel as well. I will show you in Excel, but our focus today was on RStudio. So someone raised an issue about R and Python. Let me tell you now, the difference between RStudio and Python, that is the PyCharm IDE for Python programming. The difference is that I understand that Python is better than R. But I want you to get this. When it comes to anything statistics, R is always better. But when it comes to web development, data science, those advanced data science things like machine learning, time series analysis, then Python will always beat R. But now R, when it comes to statistical analysis and data analysis, R is better. Python can never beat R when it comes to that field. You'll come to realize that the libraries in Python and the libraries in Excel, some of the names, they are almost the same, and the functions also they perform, they're almost the same. The same way you can do data visualization using ggplot2. The syntax of the code in RStudio using ggplot2 is almost similar to the syntax of the code of matplotlib library in Python when it comes to data visualization. So the difference is always small when it comes to things of data analysis and statistical analysis. But anything statistics, anything involving numbers and data, always prefer to use R. The advantage is also when it comes to data science and you want to deploy your model, you've already come up with a model to predict how many people are going to die of cholera in Wajir County. And you want to deploy your project so that people can be able to see it all over. They can just go online and search the link and see it. Then Python is better. So, I tried to deploy a certain project in R using the Shiny website, but it usually has some issues. So that's why when it comes to data science, people will always prefer Python. Python has several ways you can deploy via GitHub. You can deploy using Streamlit. I always deploy my apps using the Streamlit app. The Streamlit website for deploying PyCharm applications. So maybe you can remind me to share some links for you. You see some of the models by the time you will want to cover something in data science. So that's the difference between those 4 tools. So R has numerous libraries that enhance its capabilities to install and use them. And it's always very easy to install libraries in I'll be typing in the message section maybe 1 or 2 things. Excel VBA and micro automation. I've seen it in the message section. In 2025, never waste your time to sit down to learn about VBA and micro automation in Excel. You'll be wasting your time. No one will ever. I think since 2019, VBA was replaced by the structured query language SQL. So no one will ever ask you to do VBA. VBA, where you go and code in Excel, it's an outdated version of it's outdated, and no one will even want to know if you know it. Though sometimes it usually do some good work. I've been trying to open a project here that I did with VBA, but it's not crucial at this moment. Maybe if you want to see it, Excel can do a good work because it's more of a database. So VBA used to generate databases. So it was fully replaced by the structured query language. So never learn about that. You can try to check even online in some Excel curriculum, advanced Excel curriculum. Nowadays, VBA is gone. No industry, no company will use Excel to store its data because it's not safe as compared to the structured query language. So I was saying when it comes to R and you want to install any package, as long as you know the name, the formula is always install.packages. and then you open the bracket, and inside there you must put the is that, how do we call those two things, and then you put the name of the library. So this is how you install packages. Then after installing, you can now use them. So they are not always there by default. So we have very many libraries. We have very many libraries that I'm going to share with you after this class. They are more than 20, even more than 30, but they are the most, we have the common ones that we keep on using. So the essential libraries in our studio, number one is the dplyr library. Dplyr library, a few months ago, I used to call it dplyr, but someone corrected me and told me that it's called dplyr library. The spelling is in the in-call messages in this meeting. So that is the dplyr library. We have dplyr library is for data manipulation. Every library has its own function, and the dplyr library works together with the tidyr. Tidyr library is for data cleaning, data tidying, just from the name tidy. Okay, that's a wrong spelling. Tidyr. Okay, tidyr, and the other common one is the ggplot2, or not common, but the most essential libraries. ggplot2 is for data visualization, and then we have the readr. Readr is for importing datasets. If you want to import a dataset to our studio, maybe an Excel, CSV, you use the readr. Then the other essential library is the caret. The caret is not more of what we are going to cover, but it's a library for machine learning. And we also have lubridate. It's a common one, okay? Lubridate library is for date stroke time, not data. Date stroke time manipulation. So anytime you're dealing with date and time, we are going to install the lubridate library. So I also have a list of all our libraries that I want us to just go through them slowly by slowly, because we are supposed to cover them today. And I'm going to present my screen on that. Let me drop down this Excel so that we can. Okay, the ones that I've mentioned, the dplyr, tidyr, ggplot2, readr, lubridate, and caret are the most essential. But we have all, like everything now. Okay, we have everything that we can just go through them roughly, because why not? So I'm going to show you. It starts from here. So I've categorized them according to their function. I hope you guys can see. So number one, you have data manipulation and cleaning. When it comes to data manipulation and cleaning, we have the dplyr library and the tidyr. We've already talked about them. We have a library called the data stroke table, and it's a high-speed data manipulation. Yes, I understand that dplyr can do data manipulation, but if you are dealing with a large data set and you want it to stop loading and go at a high speed, use the data.table library. Have the janitor. Janitor is for cleaning messy data. Yeah, I think we have this ladies hostel that they always have a janitor. Don't know if it's for ladies only or for both genders. So their work is always to clean those hostels. So here we also have the janitor library for cleaning messy data. The lubridate data, it handles data and time, as I said. Number two category, we have the data import stroke export. And from data import stroke export, the essential one that I was talking about that time was talking about the readr for reading CSV text and other text files in the CSV, TXT, and other text file in our studio. We have the read Excel specifically for Excel files, okay? We have the Haven. Haven will read files from SPSS. So you'll realize when you have data data in SPSS, when you save the data, they usually have their own extension called the SPV, okay? So SPV is SPSS data. So if you want to call SPV data into our studio, use Haven. It's rare. DBI is for connecting database, that is SQL. So the DBI is also for connecting a database and importing your data. But when you go to Python, we have something called the PyMySQL for connecting Python and SQL. It's usually very interesting, whereby you are just typing codes in SQL in Python, and the changes are taking place in the MySQL workbench. For data visualization, we have ggplot2. ggplot2 In 2025, it's not good to call it ggplot2. It's good to call it ggplot2 and friends. So I have to add it. ggplot2 has more than 50 friends. gganimate, ggrepel, gg.plot, gghistogram. There are very many. And I have them also posted in the site. There are more than... Okay, the difference between all of them, these friends for ggplot2, they all start with G. So the difference is that when you want to make your work more appealing, you use the... Let me say, for example, right now, when we are trying to visualize the number of patients between different years, the 2010 to 2013, I will come up with a bar plot with four bars, okay? 2010, 11, 12, and 13. But now Kevin can decide to do what? Kevin can decide I'm not going to use ggplot2 for my data visualization. I will use gganimate. So gganimate is going to generate a plot like a video. It's a video playing from 2010. It switches to 2011, like something just appealing to the eye. But at the end of the day, we are all going to achieve a goal. We have the plotly for interactive visualization, that is also animations and all that, and we have gganimate. So these ones here, you just have to learn about ggplot2 and you're good to go. Statistical analysis, we have the stats, a library called the stats, that we are going to use it. It's built in R package for common statistical tests. So when we get to hypothesis testing and those all kind of tests that we've seen, we shall use the stats library. We have the psych, car, and survival. From all these, I think what I've used is the survival. This one for survival analysis, like the Cox hazardous model. We have this one, the car, for regression analysis, specifically regression. But the most common ones are the stats, which cuts across, and the survival for survival analysis if you want to focus on that field. For machine learning, we have Caret, random forest, XGBoost, TensorFlow, H2O. So it depends. We have machine learning breaks into two, unsupervised and supervised learning. So you will get random forest, linear regression, and all that. So it depends with which kind of model you want to come up with. But Caret will always cut across, mostly for making predictions. You will be using Caret. Text analysis and NLP, which is an advanced field, is a data analysis. You'll use the TM, tidy text, and quanteda. The last time I did some text analysis, there's a library I used that is not here. Something starting with grepel. I used to do some text analysis. So you'll get these are data analysis. Most of them are data analysis. For spatial analysis and GIS, this is it's usually a whole topic called, it's called what? It's called, I'm forgetting the name. It's called disease mapping. If you are in the healthcare field and you are doing some disease mapping, you will use these GIS libraries like the SF, SP, raster, and TMAP. But now, the alternative to this one, if you are tired of, now SPSS cannot do this when it comes to mapping. We have an application called the ArcGIS and the QGIS. ArcGIS and QGIS, I can just recall using them some time back to do some spatial mapping of diseases. So I never used these libraries, but I used the ready-made softwares that are available online at a fee. Web scraping and APIs, it depends with what you want to do, where you want to scrape your data. But most of the time, you'll get people in this field, we always use data that is readily available. But when it comes to web scraping and data and web scraping and these APIs, I will always prefer Python. Python, you will have libraries like the beautiful sub4 for data collection. Time series analysis, this is the data science field, data science topic. Of course, the forecast is the most common one for forecasting what is going to happen. That is the RIMA models. We have report automation and reproducibility using the R Markdown. This is not more of a library, but how you can save your work in R. So those are like all the libraries, okay? I don't know if you can meet, I'm not sure if you can meet another library which is not listed here, but you have seen, at least you're now familiar with the names. Our focus today is data manipulation with the dplyr and tidyr, and we have under dplyr we have what dplyr functions. Dplyr functions, these are codes that we are going to write, the formulas or functions that we are going to write in our studio, so that we be able to cover data manipulation. Dplyr is primarily used for data manipulation, and we have the key functions for the dplyr that we must cover. So I've listed all of them here, but we are only going to focus on the common ones. So I have categorized them. I wanted to make the work so easier. So just a minute. So I've categorized them here. Okay, sorry. So I categorize all the functions for under dplyr library as a library now, and tidyr, because they most of the times they just work together. So before we start going through the libraries, we have to know what is this data manipulation. Data manipulation, it involves modifying data to make it easier to read and to be more organized. And we manipulate data for analysis and maybe for visualization. It's also used with the term data exploration, which involves organizing data. So I always say, yes, we have OpenXLS library. It works hand in hand with readexl. Okay, they are just the same. Yeah, it's there, confirmed. Okay, I was saying there's a certain procedure that I usually follow anytime I am handling data. Be it in Excel, RS, any place. Number one thing I always do is data exploration. That exploration is just the process of understanding what your data contains. After exploring my data, of course, I'm going to identify some errors in it. Then I go to data cleaning. After cleaning my data, the next step I will go is manipulation. Now we are going to manipulate our data ready for analysis and also visualization. So that is the definition of manipulation. Just know it's the modifying of data to make it easier to read and to be more organized for the sake of data analysis and visualization. So these are the functions that you're going to meet under the dplyr library. Category number one is the data selection and filtering. You're going to meet the filter function, select, rename. So this function, just from the name, they already explain themselves. I don't have to explain them. Filter, we have the select, we have the rename, distinct, slice, and arrange. Under data transformation, you are going to meet mutate, transmute, record, and case underscore when. Okay. Aggregate and summation, that is aggregation, the same way you can just do that aggregation in SQL. You're going to meet summarise to compute your summary statistics. Summary statistics is the same as descriptive statistics. When you run descriptive statistics in Excel, you're going to obtain your mean, mode, median, skewness, kurtosis, minimum, maximum, range. So if you want to do that in R, you just say summarize data, the name of your data in bracket. You're going to meet the group by and then group. We are going to see some of the joining and combining function. This is like joining an SQL. We have the inner join, left join, right join, full join. All these joins are also available in SQL. So these things, some of the times they just relate. But in Excel, you don't have the semi-join, anti-join, blind rows, and bind columns. For binding columns, bind rows is of course for binding rows. That's why I say these names, they just explain themselves. Reshaping data, we have the pivot underscore longer, pivot underscore wider, nest and a nest. Okay, I will share this file with you. Working with rows and column, more important, we have the row wise, we have the count, slice head, slice tail, But the slice head and the slice tail, for me, I just know them as the head and tail. Okay, if you want to select maybe some rows in the at the beginning of your data, if you want to select the tail, you say tail data. It will bring the last 6. Slice sample, it will take a random sample, just pick any. So those are some of the functions under dplyr. Under tidyr, for tidying your data and restructuring it, that is data cleaning, you have the pivot underscore longer, a repetition, pivot underscore wider, separate, unite, nest, and nest. All of these functions are still available in dplyr library. We have the drop underscore na. Drop underscore na, anytime you see na in R, it's blank or missing values. So drop underscore na for removing rows with missing value. Replace underscore na is for replacing missing value. Expanding, we have expand and complete. Miscellaneous, we have extract and fill. Okay, so these are some of the functions that we are going to meet throughout our data. These are this class, handling data manipulation. So right now I want you to start your R. One thing you have to know is that R Studio cannot run in absence of R in your laptop. So you have to install. So if you experience errors in your R, just know in your studio, just know maybe R also has an issue. I'm presenting my screen right now. I want you to start your R studio. I will love if we move together step by step. We go. Let me present my screen for R, and we are going to start. We're going to start our data manipulation. We don't have a data set. We're going to create one together. I already shared the code. Your work is just to copy and to paste. We shall discuss everything, how it was created. Don't worry about that. So my studio is there. We're going to go step by step. You'll just be sending questions to the in. So we have 40 minutes. Okay, we are going to be sending. You just post question in the in called messages, and I shall be able to tackle every question that has been posted there. Don't worry about that. So the moment you are in your R studio, I left it at this point because there's something I was handling. I already gave you an introduction to this. I don't have to repeat. This is where you type your code. Results will be appearing here. If it's plots and visualization will be appearing in this area where my cursor is. Environment is where you'll be seeing your variables in the data that you have. Apart from plots, here you have packages. Packages will show you those packages we've been talking about. You can still see them here. So you can still see them here. So once you are in your R, I want you to create a new file. So at the top left corner, there's a white box with a plus green button, but I don't know if it's green your side. Depends with the laptop that you are using. But there's that white box with where my cursor is. You just click on it, and you create a file there. You just create it. It's going to create, and I want you to see your cursor blinking here. Okay, so once you're here, we are going to start with our data. We have our data with us. Okay, copy the code because our role here is to see how we want to see how we do data manipulation, not creating a data set. No one will ever ask you to create a data set in R. You will be having already available data sets, and even R Studio itself, it has a wide variety of data sets for the sake of practice. Okay, so you just copy the code. The code I shared in the group from library dplyr to the bracket at the end. Make sure you copy the right thing. I've copied mine. You just come here where the cursor is blinking. You paste. Sure, it's pasted. Okay. So I hope we are together. Questions, you just throw them to the in-call messages. I will be explaining everything in detail, and I believe we are going to move together. So here, I'm going to just explain my data just small. I am trying to form a data of containing these columns. We have name, the age, gender, salary, department, score 1, and score 2. So For me to create this data, I've already called some two libraries here, library dplyr and library tidyr. So because you are calling these libraries for the first time, here, where my cursor is here, I want you to be keen here under the console. You must install these libraries. You get it? You must install these libraries. I want us to install these two libraries because we are going to use them today. So I'm going to start with what? I'm going to start with the dplyr. So I just write install.packages, the one I typed in the message section. Install.packages. I open the bracket, put those two things that I don't know the name, and I'm going to write there dplyr, dplyr. Then after writing that, that is my dplyr library. I just press enter, and you give it time to so you will see here, and the moment you click on this red thing here, stop, it will stop. So you just give it time to install. Sometimes it may take time depending with what the contains. Some libraries are usually contain many functions, so they take a lot of time as compared to other libraries. So it's here, package dplyr successfully unpacked and MD5 checked. So because it's still running, so I'm going to give it its time until this red thing disappears here. So package dplyr successfully unpacked, it's okay. And then I'm going to install the second one, install.packages. It's not package, install.packages. I open the bracket, put the two. You should now tell me the name. Sir, screen is not visible, sorry. My screen is visible now. Install.packages, that is tidyr, enter, and I allow it to install. I'll be checking the message section randomly. Felix, is my screen currently visible?
Yes, it is.
Yes, okay now. So I've already installed my tidyr and my dplyr library, okay? Because that is what I want to use in creating this data set of mine here, this sample data set that I have here. So I already have them. Let me check if it has finished. So that is the procedure. The good thing is I'm recording this class, so I can still post it after editing maybe some parts that are not required. And I'm going to highlight everything here, and I will click on run. It's calling the library. It's okay, so no error. There's no error, meaning this data has already been created. So maybe I will try to check. So the name of my data is data. I will try to write, when I write head data, let me see what, I just highlight this part only, head data, because I don't want to repeat running everything. You will see when you write head data, you're going to get the first six. You get the first six. So you can say I have ID, name, age, gender, salary, department, score 1 and score 2. So when you want to get the first six entries of your data, you just write head data. If you want to get the last six, you write tail data. Okay, enter. Okay, sorry, not enter. I highlight this and I run. I thought I was in what? It's called what, SQL. I thought that's why I keep on pressing enter every time. Tail data, there's an issue with my code. It's incomplete, so I just close the bracket and I run it again. Okay, at least the error has gone. So I run it. Okay, it's here, tail data. You can see the last 6, 1, 2, 3, 4, 5, 6. Okay, so my data has successfully been created. I want to explain a little how I created my data. Number one, I wanted to create a data containing these details, ID, name, and all that. So what I did, for you to create a data, it must be a data frame. You must create a data frame. I already explained that in our introduction class. So a data frame is where your data is stored. Okay. and mostly when you want to store your data in table format. So I set it as something like a what do I call it? Ratio 1 to 10. So for this ratio 1 to 10 in R, it means that your data is going to be created from, your ID is going to be assigned from ID 1 to ID 10. Okay? Then the name cannot be assigned. So I had to write the name. And because they are name of people, I put them in those two quotations. Can you please tell me the name of those two things? I'm finding hard time. I put them in those two. Let me see if someone has typed for me in the message section. Sharon, mine says object dplyr has not found. It's because you've not installed dplyr library. Install .packages dplyr under console. Then after doing that is when you can come and run library dplyr. Without that, it can never work. Yes, so I'm waiting for someone to type for me those two, the name, as Sharon tries to solve the issue. Then the age, what I did, I ran a sample, random. I assigned randomly from 22 to 40. So it will just assign randomly the age to 10 people, 22 ratio 40. Replace is equals to true. The reason as to why I said replace is equals to true, I wanted it to assign them randomly without repeating. Gender, sample, also MF randomly. Replace is equals to true, the same thing. Then I stopped at 10, so I must tell it to stop at 10 people, or else it can keep going up to 1 million and your studio will hang. Salary, the same thing. Department, the same. So that ratio thing, let it pick by random. Sharon, can you try to solve the issue? Then tell us the way forward in the message section, because I'll not be coming. I have to concentrate on our studio. Now, to make our data ready for analysis, I want us to do many things here. So we are starting the process of data manipulation with dplyr library. I want you guys to be keen. You can do it during your own free time. Focus is important. Concentration. So here is my R studio. Anytime you put a hashtag in your data, commenting, it's called commenting. You put a hashtag like this, it means you are excluding that particular line from running. So I want us to start with filtering data, because we've already gone through all the functions under dplyr library. And right about now, we are starting the functions in dplyr. We are going to be fast, our time is limited. So we are going to start with a filter. So filtering data, that is like the heading, because I've already put a hashtag to start with. So I want us to filter data and only get people whose age is above 30. Right now here we have age, we have Alice with 23 years. So what are you going to do if you want only those people with age 30? You're going to do what? You're going to filter data. And I'm going to assign a name. Anytime you want to do a new thing, you'll be assigning a name. So this name, the name of this filtered data is going to be filtered underscore data. Okay, so this is going to be my filtered underscore data. And I was talking about assigning names. You use the less than and you put a dash. That is if you want to assign anything, assigning anything in our studio. I talked about it the other day. And because I want to assign my what do you want to filter? Your data. What is the name of your data? It is here, this one, data. So right about now, when I change this data name to Sharon, we shall be using Sharon. So because I gave it the name data, I don't want to interfere with it, I will say filter data. So filtered data, assign it to filter, and then I'm going to use the pipe indicator. The pipe indicator in this case is going to say, make changes to everything, like go through our data and make the changes that we want to do. So the pipe indicator is a percent greater than percent. That is what we call the pipe indicator. It's available in the dplyr library. Filter. So filter is a function by itself now. You can see it's here. And R is like Excel. You can see it's telling you what does filter do. Keeps rows that match a condition. So It just tells you what the function do. So data pipe indicator filter, and then I open the bracket. What do you want to filter in this case? I want to filter age for only people who are above 30. So age above 30. You see what I'm going to do? And then I'm going to run this filtered data. I'm going to run. So after running, I want to do what? I want to show my data. So I want to show my data. Let me see. Print filtered, because that is the name I assigned to it, filtered underscore data. And then I run this print filtered underscore data. You will see it has only brought people whose names are above, whose age is above 30 years. Okay, so this pipe indicator here plays which role? It directs our function to go and observe everything in data, in our table called data. Then I use the filter function, and in the filter function I put in the bracket my condition, my criteria that I want to be met. Age should be above 30. So that is if you want to filter your data. Number two, I want us to do what? I want us to do what? To select some columns only. We don't want to showcase all columns. So this one, hashtag selecting columns. I want to select some few columns. If you want to select some few columns, so I'm going to call it what? I assign a name. Selected underscore data. Selected underscore data. I assign to what? What do you want to do? It's your data. This one here, the one that we have already formed. You can see it appearing in, this is the table. Okay, so data, I must put the pipe indicator to tell it that it must go to everything, to the whole table. Pipe indicator. Then I will use the select function. And under the select function, what do you want to select? I say the columns that I want to select, maybe name, comma, age, comma, what? Salary. Then after doing that, I want to print my what? You print now. The name that you assigned is what? Selected underscore data. Then I run. Object selected data not found. Oh, the error here is the name. Selected data. Okay, I highlight that part only. I run. You will see only the columns that I have selected here using the select formula, name, age, and salary, have appeared. Okay, the other thing I want to do is to rename columns. So hashtag renaming columns, enter, and I'm going to assign a name called renamed data. Okay, renamed data, I assign to what? My data. I put my pipe indicator percent greater than percent. Okay, and I want to do what? To rename. I use the rename function in tidyr, not tidyr, in dplyr. Rename. What do you want to rename? Earnings. We had earnings, a table called a column called earnings. Earnings. Okay, earnings is equals to what? Salary. Instead of earnings, I want to use salary. Then I'm going to, because at that time we had, when we viewed our data did we had earning? No, it's department. So you must begin department. Instead of department, I want to have depth. You get it? And then okay, this was our data. It had department, and then I'm going to enter. I print what? I print my renamed underscore data, and I run this part. Error, column depth doesn't exist. Okay, there's an issue. Let me see. department is equal. Oh, okay. I'm seeing where the issue is. I must interchange. Here it's supposed to be, this one is supposed to be department. So the one that appears should be after the equal sign. I want to rename it to depth. And then I am going to rerun this part. So you will see, instead of department, right now I have depth. Good one. We proceed. Another formula under dplyr that you have to know is removing duplicates. So I want us to removing duplicates. How do you remove duplicates? This one I'm going to assign a name. I can hear some. Oh, okay. Removing duplicates. I've seen an issue. Okay, no problem. I'm going to remove duplicates. Distinct.
Excuse.
Yes.
Okay. I have an error here. When
Okay.
I write the code of filtering data, something pops up. Error fetching key. Let's say wrote database.
Error is fetching.
Okay, I've sent you a screenshot on WhatsApp of the pop-up over. Yeah, maybe you can see.
Let me check this error where it comes from. dplyr.rdb error in fetch key. Okay, have you seen your after filtered data where you assign the name filtered data, the pipe indicator you've not written it well. It's supposed to be percent, the greater than sign percent. Have you seen it?
But actually the error comes even before writing that. You see when you write right now when you write this thing.
When you write?
When I read the word filter. Yeah, and there's a pop-up comes that is selecting that either you select the name from the ad gives you the name, right?
Okay.
But when I click maybe tab so that it can write the name, it brings up the pop-up now that I've sent you.
Okay, you have to avoid to pick the. Sometimes there's that issue that also I think sometime back, Sharon, you had the same issue. There's this issues that appears in our studio when you want to autofill, because you've seen when I'm typing filter, there are some options that appear that I can just select directly instead of typing. So you'll get sometimes when you select them from the list that appears, it keeps on generating the error. So this makes you to just keep on typing, like you just have to type everything. That is the issue that I also find sometimes with R. I don't know, it's because of their updates and what. But you just make sure your pipe indicator is written well. And what about, apart from filter, have you done the selecting of, have you used the select formula?
Actually, this is what happens.
Okay.
When now, for example, I write the word select.
Yes.
Before I finish even writing the word select, that pop-up comes.
True. Is your dplyr library well during the process of installation of the dplyr library? Did it install well?
Yeah. Yes.
It installed
It
well.
was successful. Yeah, it was successful.
Okay, I want you to go to your console and then try to run installed.packages so that you can see the packages that are already installed. So you just write install.packages, then open the bracket at the console and you press enter. at the console. The message section here. Where is the message section? Okay, just a minute. Okay, it's here with me. Installed dot packages. Tidyr is one of them.
Which it brings up a pop-up.
Okay.
Let me check. This thing you can't write select must.
Maybe as he's trying to sort of, could you please scroll up in your console so that I see how you wrote the code for installing the two packages? Because I was trying that it's still giving me the error.
Install dot packages. Here, this one.
Yes.
It's here.
Okay.
Install dot packages dplyr. Oh, sorry, I've scrolled again. It's here. I will type it in the message section. Let me put it here. Yes. Can we proceed?
It's like TDR is not installed.
Uh-huh.
I have something called I don't have I don't have.
You've already run the installed dot packages.
Yeah, let me just reinstall. I see if I will get the same problem.
Install as many times as possible. Sharon, what is the progress with your installing of dplyr library?
I've managed.
Good one. So we are waiting for Kevin.
I think we can continue.
Okay, so I will still share the video with you guys. I'll still share the video with you guys, and we shall have all the time with us questions. So don't worry about that. Okay, let me proceed. I will say removing duplicates. For example, if you have duplicates in your data, this is some sort of data cleaning. So you want to remove duplicates, distinct data, that is the name I've assigned. You can give any name. I assign it, that is my mark for assigning my data. I put my pipe indicator greater than % again, and I use the distinct formula that is available in a dplyr library, and I want to say department. Maybe you want to remove duplicates from department. Okay, so this, remember, we don't have we no longer have department. We have it. We have, because we are not talking about renamed data. We are talking about data. Okay, so it is there, but the caps must be okay. And what you are going to do after doing that, I'm going to print my what, my distinct underscore data. So let me try to run. I see department. You see, so duplicates were finance, HR, and IT, because you can see we have duplicates in HR, in finance, and IT. Yeah, so these are some of the duplicates from our data. So these things will deal with duplicate values. Then let me say you want to select selection of your data. Again, here we selected columns, but now if you want to select under a condition, let me say by rows. Okay, there's something we made. Select, let me hashtag it to comment. Hashtag, I want to select rows by position. There's some new thing I want you to learn here. Here, I'm going to call it my sliced data, because I want to select some portion of it. I assign, and then I want to deal with my data, percent, or greater than %. That is my pipe indicator. Slice. I want to slice my data. That's why I've called it the sliced data. So I use the slice formula that is available in the dplyr library. So slice, and I want to slice 1 to 5. I want to show you what happens. Then I'm going to print my what? Sliced underscore data. So run. What have you noticed? What has this thing done? It has taken the first 5. Okay, it has printed the sliced data is from 1 to 5. So if you wanted maybe from 5 to 10, then this was going to be, or from 3 to 10, 3 to 5, sorry. I want to run that part alone. You will see 1, 2, and 3. So it has just taken from ID 3 to 5. You get? So there are only 3 of them, 3, 4, and 5. So it has sliced from row number 3 to row number 5. So select rows by position, use the slice formula. Then, if you want to sort your data, maybe, okay, let me see, salary. Okay, let's arrange our data by according to salary, how people are receiving salary. So I'm going to comment this one is it's sorting data, enter. Then it's going to be sorted underscore data, and I'm going to assign it to what? My data, my pipe indicator as usual, and I'm going to arrange. Okay, this arrange is a formula for that one. So I want you to learn something here. You want to rank by salary. This I want it to be in we have ascending and descending, to be in descending from the largest to the smallest. Okay, so if it's ascending, you use ask, the same thing that we did in SQL with the data analysis guys. If it's ascending is ask, if it's descending is desk. So descending desk. What do you want to arrange in descending? You open another bracket, your what? Your salary. We have it, but the salary S was capital. You need to be very keen. Salary, let me give some space here. So, and then after doing that, I want to print what? My data that has been sorted, the one that is the name I gave it. So I want to run this one. Object data not found. Sorry, here the spelling is the matter. Okay, I want to run this part, sorting data. I run. You will see, has it arranged by salary? Yes. 89,000, this one is 50,000. If it was ascending, it will be, I said it will be ask. Let me try to run and run, printed, ask. I don't know, it's not ask. Let me try as say, but it's supposed to be ask. Let me confirm. This is okay. I'll remove this one, arrange. Let me try this. Okay, this is from, okay, yeah. So if it's from ascending is small to large, you just don't put anything. But when it's large to small, it's desk, so you have to include desk inside here. I will open, write desk, not supposed to open here, desk, and like that. Okay, then that is if you want to sort. So if it's ascending, you don't put anything, you just say arrange. So if you want to, what if let's say here we have salary. Let's say there's a bonus. People have been added. So you have to create a new column. That is the easiest thing. You want to create a new variable. Create new variable. Uh, create a new variable. We are going to use mutate. It's for adding another variable. So I'm going to call it mutated. Mutated underscore data. I assign to what? My data. I put the pipe indicator greater than percent. I use them. So you're going to use the mutate formula for adding a new variable. What is the name of that variable? Bonus. Bonus is what? Is equals to what? Let's say bonus is salary. Salary times in R is star times what? 0.2. You get? Then after that, I want to print my mutated data. Print mutated underscore data. So this, if you want to add a new variable, you do this. So print is just for showing results. Symbol in creating, unexpected symbol in creating new. Let me see where is that error coming from. Mutated underscore data. Okay, here. I've not hashtag this. It's a comment, not part of my code. I run this. you will see bonus, it has been calculated, you get. So yeah, just like that. The other thing, maybe the other formula under dplyr library is we talk about mutate. We can talk about maybe assigning condition. So conditional column, it's also something that is common. I want to show you. So you want to do what? Conditional. The spelling is bad even though it's a comment. Conditional column formatting. Sorry. So I want to transform my data. So I'm going to call it transformed underscore data. And then I'm going to assign to what? My data, of course. Pipe indicator is what? Follows greater than. After that, I'm still going to mutate because I just want to add some new field, but now to that meets a condition, a new field that meets a certain condition. So it's going to mutate, and I'm going to open the bracket. I'll say salary category. This is what I'm going to say. Okay, I'm adding a new code. It's not only about adding a new column like mutate here, but a new column that meets a condition. That's why it's called conditional column. So salary underscore category is equals to, I will use the case underscore when. It's also a formula itself. You can see it here. It has displayed, and it's from the dplyr library, a general vectorized if else. So it's a formula. I've not just guessed it. So case is equals to when I open the bracket, then I will say salary is greater than, we use 80,000, no comma, my values have no comma, 80,000. I assign it to shift. Now this keyboard is going to show me total dust. I don't know where that mark of assigning is. Okay, let me just get it. No, my keyboard is not the normal one. Assigning mark. Assigning mark. Just a minute. I don't want to spend a lot of time on my keyboard. I just go search it online and copy it. I come and paste here. Okay. So that thing, there's a name there. I don't know, but I want to show you. It's always in the keyboard near enter, but my keyboard is complicated. I want you to see it. This thing here. So Control V because I've copied that thing. Have you seen that thing? That one. That's what I'm talking about. So if it's greater than 80,000, I comment high. Okay, comma, salary again, like this, just a condition like in Excel. Sorry, I have to get out of this thing that you never told me the name. Salary greater than 60,000. 60, 1, 2, 3. Then again assign, like that's the thing, that one. I know it's in your keyboard, that thing. I put a median. Medium, not medium, medium. And then I want to stop. Otherwise here, I'm going to use true to mean otherwise. True, again, put that thing. I assign a low. So any value that is not falling in this category of 80,000 and 60, it's going to be low. Low after low, how many brackets? I have to close 2. Then I want to print my what? Transformed underscore data. I want to see if it has happened. Oh, there's an error here, guys. Spelling of data is not okay, so it will not work. Data. Yeah. Have you seen, guys? So I've created a new column that meets a condition. So the only new thing here, the difference between this and this one, for just creating a new variable, this one meets a condition, and here is the condition I've set it, and I've used the case when. So salary category is the name is equals to case when, then you put the cases in bracket. So otherwise in Excel it's usually a comma, in SPS, in R, in SQL it's a comma, but in R it's true, meaning value that does not follow under these two categories that have been mentioned, just assign a low, and you can see the salary category has been created. So that's about creating new variable. I must talk about this. I was forgetting. Summarizing data, very common when it comes to data manipulation. Summarizing data, it's very easy. Okay, I'm going to use summary underscore data. And summary, this spelling is right, even though it's just a name. Summary data, you assign to, and that's your data. What follows? The pipe indicator greater than. I want to summarize my data. How? I want to group by salary. I want to group by department, because these people, there's finance, HR, IT. So the first thing I want to group by department. After grouping by department, so the first thing is to group. After grouping again, I go through all the data and then I summarize the average salary and get the mean by department. So you're going to use the group by. Do you recall me talking about it in functions under this one? So department, group by department. Then after grouping by department, what next? You want now to summarize. Okay, so what next? You again put your pipe indicator, because you've already grouped your data. Then you want now to summarize. You must go through it all again. So you put the pipe indicator, and then I say summarize. Okay, summarize is a formula under dplyr. You can see it here. So summarize, for getting a summary. So the column name, I want to give the column name, I want to call it average salary. Average salary is equals to what? How do you calculate mean? How do you calculate average? It's mean. Okay, so mean what? Mean of what do you want to get? Mean of salary. You get, so mean in bracket salary. Then after that, I want to print my summary underscore data. Sorry, how to do this, and I run. Have you seen? Very interesting. So department and average salary. So the first thing I grouped by department, finance, HR, IT. After grouping, I again went through all the data, pipe indicator. Then I summarize the summarize formula. Average salary is equals to mean. Mean of what? Your salary in bracket. Then I printed my results. So I've summarized my data by department. So maybe if I just wanted to get a summary of all, go through this process of grouping by, but I just wanted to cover the grouping by so that we don't fail to cover it. Maybe the other thing, because we've learned how to group, we've already grouped now. What about ungrouping? Ungrouping data. Ungrouping data, I'm going to give a name, ungrouped underscore data, and I'm going to assign, that is a name I assign, summary, because I've already grouped my data. My group data is called what? Summary underscore data. So I want to ungroup it. I must add, now this time it's not going to be data. It's going to be the data I've already grouped. And in this case, it's what? Summary data. This one here. This one. You can see it's appearing in this box. Summary data. And I must put the pipe indicator to mean that it must go through all the data in that table of summary data. And then I say ungroup. I open the bracket, so it ungroup. Because ungroup is a function, I must put the brackets. Then I'm going to print. We are past time, but we are finishing. I'm going to print what? What is the name of assign? Ungroup data, ungroup underscore data. Come here. I run. You see? Department and average salary. So, print ungrouped data. So what happens here is this data has been ungrouped, and we can now work with it as ungrouped data. So if you want to ungroup, you must use this ungroup. Then the other thing maybe that I want to finish on with this dplyr. If you want to join, it's important. Just hold on. Joining data. What can we join here? Maybe we want to join let me see, extra, let me call it extra underscore data. Sorry, extra underscore data. And my data is stored in a data frame, so data underscore frame. Remember, I want to join, so I have to go back to my data frame, this one here, because I want to add data there. You get? So data frame, I will come, I say ID. Then initially our ID was 1 to 10. In fact, this joining data, it is something that it's hard to use it, because we said no one will ask you to create a data set from scratch in Excel, not Excel, in R. So initially our ID was 1 to 10. So I'd say performance is equals to sample. I will explain what I'm doing. Let me say sample. I pick a sample of 1 to the 5th value. After picking a sample, I want to replace them. Replace is equals to true. Replace is equals to true. After that, I'm going to name to create a new name here. Assign it to my data. Now my initial data. Of course, data will be followed by a pipe indicator. And I'm going now to use the inner join, because I want to join them. Do you recall me talking about some joins as functions under the dplyr library? So I'm going to use inner join. You are going to get it from the table that I'm going to generate. So extra underscore data, it's this one here, the one I'm trying to form here. Extra underscore data by ID. By is equals to ID is a column name, so I put it in those 2 marks that you never told me the names. And I'm going to print my extra underscore data, and at the same time I'm also going to print my what? I'm going to print my what? Join data. I want to see all of them, how they've appeared. So let me run all these. Okay, so extra data here, I went back to my data frame where I had ID number 1 to 10, the one that we had initially. Performance, I ran a sample of 1 to 5. You get? So this is a new column. I just formed a new column called performance for these people, and I added some performance rates. Let's say I said 1 to 5. Remember, I tell you any ratio means you are assigning, you want it to assign a sample randomly in the ratio that you've put there. So 1 to 5, I wanted it to assign performance randomly. So it has assigned performance, and it should stop at the 10th value, because we have ID 1 to 10 as well. So you see, replace is equals to true, meaning it should avoid repetition, because if you don't say replace is equals to true, it can go 1, 1, 1, 1 up to you have 1 appearing 10 times, which is not good. Then after doing this one, extra data, the only thing I've done is add this column called performance. Then I joined my data. How? I joined this data here by ID. Remember, by ID, meaning the way this data is appearing here, ID, I know you've already get it. ID and performance. ID1 should have a performance of 3. You can see here in my data that I had initially here, the one I formed it here, performance has been added, and this was matched by, the performance were matched by ID. So it's like they share a common field. Here ID is a primary key and here is a foreign key, if you know about database management a bit. So it's I joined by I used inner join to join extra data to my joined data by ID, and you can see performance was added here. So join is rare, but you can find it. Okay, you can find it. The last thing about dplyr library is about binding rows and columns that I mentioned, and I feel like I have to cover it. So binding rows and columns, remember we had row bind and bind columns, bind underscore rows, those are the formulas. So I want to show you the results for binding rows. You assign this to what? To this formula for dplyr. It's called bind underscore rows. And what do you want to bind? Data. I want to show you what will appear. Or let's do the same. Okay, let me first print this. Print, because it's a repetition for column, but let me first do this. Combined underscore data. You will see what is going to happen. Combined data not found. Combined rows. It's not combined data. I'm getting it wrong. The name I assigned is combined rows. Sorry for that. So I run it. Okay. So I have what I was doing here is I've used my bind rows to bind the rows of my data. My data is here, where I had rows run from where to where? From left to right. Okay, so you'll get the difference when it comes to column, and I have to do it for combined columns. Let me just assign a name: combined underscore columns. Then I'm going to assign to bind calls. That is the formula: bind underscore calls, not call. I'm going to bind how? Data, comma, because you have to bind two tables. So my first one is called data. Let me bind with this one here we created. It's called the extra data that contain performance. Extra data. Then I want to print my what? My combined calls. Okay, combined underscore calls, and I'm going to run from here to here only to avoid repetition. Run. Have you seen what is happening? Yes, so it has just added, like, our extra data contained ID and performance only. So you can see after listing the columns for data, again it has added ID and performance. So if you are like wanting to combine two tables, in Excel we call it XLOOKUP and VLOOKUP. If you want to combine two tables, you'll use the column ones. Okay, then for us, I know you are not able to identify any effect because I think our sample size is small, but I hope you can see it, because what did we do? We binded our data by row, data and data. Do you know what happened? Data repeated 1 to 10, again 11 to 20 repeated, ID 1 to 10. So data typed itself, then data. I hope you can get it. So right now we have 20 instead of 10. We have 20 having been, it has just repeated. So it adds another columns at the bottom. So if I was to add here, if I here under columns, if I was to do this, let me run. I show you what I'm trying to explain there in columns. You see, it's taking time. Sure, it has brought. Have you seen now? It's just repeating the same thing because I'm binding data and data. So it's not a big thing. Maybe if you want to combine your data. So you see, we've covered all the functions for dplyr, and you will never meet something apart from what we've covered. But remember, the funny thing is that we had functions in dplyr, and we had functions for tidyr. So we've only covered those in dplyr, and we are past time. But tidyr was not that much. It has like 10 functions, and so I can cover 5, then you guys can cover 5. We just share, because tidyr, it doesn't have a lot of stories, like things are not that much. So quick one, we can just cover tidyr. The first thing we are going to start with tidyr. Remember, tidyr was more of converting data, splitting a column, doing this, just many things there. Handling missing values, which is common. I will start with that one. So hashtag, I want to start with handling missing data, handling missing data. So by 10:20 shall be done. So I want us to check. If you want to check a row in R, this is what you always do. What is the name of our data? It's called data in this case. That's what we formed. So if you are talking about a certain row, let's say you are talking about age, you do this. You say data $. Is that a $? Yes, $age. This means you are talking about the age column of the data. So if our data was called Sharon, it will be Sharon $age. So it depends with the name you assign your data. So data age, I want us to pick an age 3. By 3, what do I mean? The third age in our data. You get it? Then I'm going to assign it to what? NA. NA, I said it's a missing value. Do you recall? Okay. Then I'm going to clean my data, so I'm going to call it data. Remember, I have already dropped the third value in my age. So I've assigned it to an NA, meaning right now, if you read it, it is NA. Maybe we can try to see that. Print data. Okay. Have you seen what I'm saying? It's here NA, the third NA. Okay, let's proceed. I'm going to hashtag this because I know go use it again. Hashtag, so that I can proceed in my code. Okay, so after putting it, now we have our missing value in our data. So this is how you handle missing data. If you had missing value and you want to clean, I assign a name, data underscore clean. I assign to what? To my data, of course, what follows, my pipe indicator, pipe formula, and then I want to drop underscore na. Do you recall that formula? It was for doing what? Dropping missing value. So drop underscore na, and you tell it, or drop underscore na, you tell it to drop where exactly? In the edge. You get it? Then I'm going to fill it. So data underscore fill, or let me try to print so that we get to see the results as we move on. Print data underscore clean from here to here. Object data. What's the issue here? Here. Data. Okay, I run. It has dropped the missing value. Yes. In fact, it has dropped the whole row. You get? We don't have now that row of who. Who was that person with an NA in age? Charlie. Charlie is no longer there. So that's how it works. But before that, let me comment on this so that I remove it. I want to fill it, so it's going to be data underscore fill. Maybe if you want to fill, I'm going to assign data underscore fill to my data. Of course, I put a pipe indicator. That's what follows. After putting a pipe indicator, I use the fill formula, if you recall it, under tidyr. Where do you want to fill? Which column? Age. There's this formula called dot direction. You will see it. You can see R will tell you direction in which to fill missing values. Currently either down or up. So it can either be down, up, or down, up. Okay? Those are the only options you have. How do I want to fill my missing value? Down. I want to see what happens. down, and I'm going to print my data underscore field. Let me see what the results. Sorry, yeah. Why do I keep on missing on the spelling of data? I'm going to run this. Charlie is back with 38. Guys, have you seen what has happened? Bob is 38 years of age. So what we've done, we've filled dot direction is a formula. You must specify either up or down. So the value that is there up, like, it will just go down. Okay? It will just go down and it will be filled. So if you write up, we will expect Charlie to be 28 years of age. That is what happens with the. So can you see we've cleaned our data because we assigned a missing value, then we've dealt with it. We've dealt with it using the edge dot direction. Not edge dot direction, dot direction formula, where you can either use down up or down up, where it can pick on any. Then what has remained under tidyr is maybe combining columns, expanding your data, converting to wide format, splitting. So you can either split or combine a column. Then you have converting to long format. So how many are they? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. We've covered one, and I can cover this one, long format, and then I will leave the rest for you guys. We have a minute. Hashtag, I want to show you how to convert data to a long format. Convert to long format. Enter. So I'm going to assign a name, long data. Of course, I use my assign data. What follows is my pipe indicator. And I'm going to use, do you remember this formula? Pivot underscore long, longer. What does this formula do? Pivot, longer. They've already given you a syntax, so you can just copy and paste and use it, fix the value responsibly. But I want to do with the columns. Columns is equals to C. Score 1. We had score 1. This is a sample for the columns, and score 2. Comma names. Names. I want to change names to is equals to test, comma, values underscore 2. So this is the formula itself. You can see a string specifying the name of the column to create from the data. So R is just explaining to you. It is equals to, so names to test, values to score. No, this must be inside those 2 marks that you refuse to tell me the name. And the next thing I'm going to print what? My long underscore data. Long underscore data. Let me run, I see the changes. Why should I keep on confusing on the data spelling? Okay, it's here. Okay. I want us to see what has happened. So column score 1, score 2. For the column score 1, score 2, here I said we had 2 columns, score 1 and score 2. So the first one, I changed them to test, the column name. Instead of score 1, I had test. And the values I changed to score. Okay? And it has kept on interchanging, score 1, score 2, score 1, score 2, score 1. So it depends with how. And this one has maintained, score 2 has maintained. So I've dealt with this score 1. So converting data either to short or long format, it's more for data cleaning, and I think data cleaning is something that has to be covered on itself. So I want you to do this. Number 1, what we've not seen. In fact, you'll start with convert to long format. you will go and check convert to, I have the codes I will send to you for this particular data, convert to wide format. We have splitting a column, you'll check it, splitting a column. Number 3, this is like assignment, is combining columns. We've seen it though under dplyr. This is under tidyr, combining columns. And we have nesting data. What is nesting data? You are the ones now to tell me. For now, I know a bit. Nesting data. We have expanding data. Missing values. We have maybe the last one, extracting data using, it's called using, there's a formula here, using regex. Yes, I just recall it. So these are 1, 2, 3, 4, 5, 6. These 6 topics now. I want you to take time and cover them. I can share some sample codes for this particular data so that you can see how it works. And